Today we are going to discuss about integral calculus. In this integral calculus, the first topic is indefinite integration. Introduction of this indefinite integration, reshoot of the topic. Let us see. Students, you know the differentiation process. You studied in 11th standard how to differentiate a function. That means the differential coefficient of a function given as d by dx of sin x square. Its derivative is sin x square, derivative is cos x square, derivative of x square is 2x. This is, how to differentiate. Similarly, if you want to differentiate the derivative of a function, say sin x, simply you say cos x. Now the process is here, when a derivative is given to you, how you are going to find the function. Let us see one example. For what function derivative gives x square? If you differentiate a function, you will get a x square. X square is given, derivative is given, you have to find the function. Simply you can say that this is nothing but x cube by 3. See, what is the derivative of x cube by 3? X cube derivative is 3x square, 3 cancel, so you will get x square. Now you have easily identified the function when derivative is given. But this is not always. See, for what function if you differentiate, you will get log x. Really saying, little bit this is tough to you. See, here the student has to know the inverse process of this. That means one function, another function, if they are inverse to each other, now you can easily get the values of these functions. See here, differentiation and integration are inverse to each other. For that, we studied from school level onwards about the inverses. What is the multiplicative inverse of a number a non-zero number a? You say easily the multiplicative inverse of a number a is a power minus 1 or 1 by a. If you multiply a number, a non-zero number with a reciprocal of this, after cancellation you get 1. And from the matrices, if A is a non-singular matrix, what is the inverse of that matrix? A inverse is the inverse matrix. Of course, a number is there. For that number, what is the additive inverse? What number? Suppose you say number is 2. What is the additive inverse? Minus 2. Cancel. You will get 0. Like that, for every problem, you can say that function, you can say that for one function there is inverse, like multiplicative inverse or additive inverse, like that. In the same process, for derivatives also we can expect inverse functions. That we are going to learn. Now we are going to discuss about the inverse to each other functions. Let us take. To take an exponential function, y is equal to a power x, where a is positive, not equal to 1. For this exponential a power x, the inverse function is x equal to log y to the base a, where y is positive. So the inverse of a power x is log y to the base a. Similarly, you take a function y is equal to sin x, where x belongs to closed interval minus pi by 2 comma pi by 2. For this, the function is x is equal to sin inverse of y, where y belongs to minus 1 to plus 1. So the inverse of a power x is log y, the inverse of sin x is sin inverse y. So these are two inverse functions to each other. So like that we are going to discuss the inverse differentiation also. The inverse process of differentiation is nothing but integration. Now we are going to discuss about antiderivative. Before introducing the inverse process of differentiation, we are going to define a word of antiderivative of a function. The antiderivative of a function is defined on an interval I. For our purpose, we take the interval I in an open interval a comma b. Let us see the definition. A function capital Fx is called an antiderivative or primitive of a function fx on an interval I if capital F of x is differentiable on this interval. If this capital F of x is differentiable function on interval I, then the small fx is called an antiderivative. Differentiable means what, sir? The derivative of this f prime of x equal to fx. Then we call this small f of x is a antiderivative of capital F of x. Let us say that if this function is not differentiable on that interval I, you cannot find the antiderivative. Let us see one example. If capital F of x is root x is an antiderivative or primitive of the function f of x equal to 1 by 2 root x on the interval 0 to infinity, because this function is defined only from positive values of square root of x and 0 is not included. So for this function root x, you can say the derivative is nothing but 1 by 2 root x. So once again students, f of x is equal to root x is an antiderivative or primitive of the function f of x equal to 1 by 2 root x on 0 to infinity, since root x derivative is 1 by 2 root x. So this is the definition of antiderivative of a function. The function f of x equal to x cube is the antiderivative of fx equal to 3x square, since f dash of x is equal to 3x square. So for the function fx equal to x cube, it is the antiderivative of f of x equal to 3x square. f1x equal to x square, f2 equal to x equal to x square plus 1, f3x equal to x square plus 2. All these are the antiderivatives of the function f of x equal to 2x. See here the different steps of the graphs we took here. Y equal to x square, which passes through the origin, x square plus 1 shifted to 1 unit height, x square plus 2 shifted to one more unit height, like that. All these are having the same tangent, which is nothing but 2x. So these functions are the antiderivatives of a function of 2x. So here students, we can say that for a function there will be infinitely many number of antiderivatives will be there. So we can also replace this as an arbitrary constant. You can say x square plus c I can write for this function. So by giving two different values of this c, you can get the different function values. That means x square plus 1, x square plus 2, like that. If capital Fx is an antiderivative of the function small f of x on an interval a comma b, then capital F of x plus c is also an antiderivative of f of x, where c is any constant number or arbitrary constant. Just now what we discussed about antiderivative definition. If capital Fx is antiderivative of a function small fx, capital F of x plus c is also an antiderivative. Let us see the proof. We have capital F of x plus c derivative. The derivative of capital Fx is f dash x. Any constant derivative is 0. I got f dash x is nothing but f of x. So whatever you add the number here, the differential coefficient comes only f dash x. Look at the diagrammatic wise. If a function is taken from open interval a to b, f of x is whatever you take the antiderivative, the same antiderivative will come for f of x plus c also. That means if you shift the graph so many heights, either if you go on vertically upward or vertically downward, the antiderivatives are getting same only. Now, the definition of indefinite integral. Definition: let f I to r be a function and a capital F be an antiderivative of small f on the interval I. Then for any real number c, capital F of x plus c is called an indefinite integral of small f on I. See, this is symbolically written as integral f of x dx. What is the meaning of these symbols? Let us see. F of x dx you read as integral f of x dx. You totally read as integral f of x dx. And this sign is called integral sign. Actually, this is took from the word summation. You know summation, S-U-M-M-A-T-I. So in that the first letter is S, that is extended form of that. Summation means adding up, integrating. So that is the symbol we took here. And coming to f of x dx, what we call this f of x dx? Element of integration. F of x dx is called element of integration, and fx is called integrand, and x is called variable of integration. Totally we say integral f of x dx. Once again students, this is a symbol took from the word summation, s letter extended form, integral sign we call. Integral means summation, summing up. And coming to f of x is called as integrand, f of x dx is called as element of integration, and the variable x is called variable of integration. So clearly integral f of x dx is nothing but capital F of x plus c. This capital F of x plus c is called the indefinite integral of f on an interval I.